Hi, in this video I'm going to demonstrate how to set up an emergency light. Here I have a 12 volt LED floodlight. It is a 10 watt unit. Now just be careful, this is not an off-the-shelf LED floodlight. This is a special purpose LED floodlight. Why? Because the voltage is 12 volts. Regular floodlights operate at the mains voltage. So here, for example, this is operating between 200 and 260 volts. In other countries, you would have a floodlight, maybe it's 110 volts. But the point is that this particular one is an AC LED floodlight, while this one is a DC 12 volt floodlight. Now you don't have to use an LED light such as this. You could use any 12 volt LED light. The purpose of this explanation is to show you how to set up your emergency light, and in my case I'm going to add an additional step. I'm going to make mine only operate in the night. So I'm also going to add this day-night sensor so that the LED light comes on at night, because this is for an outdoor installation. If you're going to be using this indoor, maybe you don't mind it coming on even in the day if the mains is off. Right, so over here I'm going to show you the power supply that I'm going to be using. This particular one is made by a company called Electronic. I'm not specifying you should use this exact one. In fact, there are lots of power supplies on the market. I'm just using this one in this explanation. Now how it works is it takes the mains voltage and current coming in. So this plug here is the country specific plug. Yours would look differently, and this feeds the power supply from the mains. So this is your AC connection. So it comes in over there. There you'll see there's a little plug. Now in other power supplies you'll find that you can wire the mains supply wires directly onto the circuit board. You'll just be unscrewing them: live, earth, and neutral. In this case it's connected as a plug like this. So there you can see the brown, green and the blue wire: live, neutral, earth. Now this particular power supply has several outputs. You can see it's got 6 outputs. I'm only going to be using one because I only need to power up one LED floodlight. Most of the power supplies only have one output, so you can follow the same procedure just using the one output. Now the purpose of this power supply is that it provides you with a battery backup. And that's the whole purpose. So you plug in the mains with the AC, and then it is going to run as a backup power supply with this big 17 amp hour. Sometimes you can get an 18 amp hour battery. This is a lead acid battery, and it needs to be connected to the power supply with these 2 leads over here. So I'm going to have to connect these 2 leads over here, and even if I do connect them positive to positive, negative to negative, you'll see that the main board actually powered up. There you can see it's powering up, because now it would be effectively running from the battery because it is unplugged. So in this case what would happen is, if you plugged in your LED floodlight, once the battery is online, the LED floodlight would come on. Now the purpose of this video is to show you how to get this to work if there's a mains failure. So we only want the light to come on when the mains has gone off. And I'll also show you in this video how to do it if you want to connect it outside and you want it to only come on if it is dark as well. So that would be 2 conditions: mains failed and it is dark. So that would be for an outdoor installation. Right, so the first thing we want to do is wire this up. Now what I've done is I've connected the LED floodlight, and here I'm going to plug in the power supply and the floodlight should come on. So there you can see the floodlight has come on. Now if I unplug the power supply, you can see that the light will just go off because there's no battery backup. So ultimately that's the purpose of the battery, is that the battery is going to provide that backup power. So we need to connect the battery to these terminals over here. Now these are the charging terminals from the power supply. Right, so here I've disconnected the charging cables, and now what I'm going to do is I'm going to take the red to the positive side of the battery. How do I know it's positive? Well, either it will have the positive sign or it will be red. There you can see the cross telling me it's positive. Right, now I just need to connect the negative side. Right, so now I have the positive and negative of the battery, and I can connect it to the power supply. Right, now the LED light is on, it's running off the battery, and if I plug it in here, look what happens. The light stays on. So we need to make it that the light only comes on when the mains has failed. Right, so over here I have my multimeter, and if I measure the voltage across this battery while it is plugged in, there you see it's 13.87 volts. Why is it higher than 12 volts? Because it is charging the battery. If I unplug the power supply, now it is unplugged, it is now going to be using the battery to power that LED light, and you can see how the battery voltage is starting to drop, and it'll get to about 12.3, 12.2, and it should stay there for quite some time. So there you can see it's dropping slowly. Why? Because it's no longer being charged. Now on this particular power supply, there happens to be a mains fail notice or warning here. So what this means is if I connect the positive to the mains AC fail and I connect the negative to the negative anywhere, so there's a negative, you can see that my meter is reading 2.28 volts, but the power supply is plugged in. Now when I unplug the power supply, watch what's going to happen. There we go. It's realized that the power supply is unplugged, the mains is offline, and can you see that it went high or went to a 12 volt? So that means that if I plug this back in, you'll see that it'll go back down to that 2 volts or thereabout. Right, there we go. Why am I saying this is because this little connector over here is actually providing us with a signal which we can use to operate a relay to switch the light on or off. Right, so I've drawn a little diagram. There comes the mains into the power supply. The power supply is converting that down to 12 volts because we only want 12 volts for our light. All right, so this is your LED light in this case, and it's fed from this 12 volt battery, and the voltage here is plus minus 12 volts. Now what we want to do is we want to open the circuit when the mains is on. So on means open and off means closed. So this little switch here should actually close when the mains goes off. So we need to have a controlled switch. So what we can use is something called a relay. There's a relay. In here are lots of different types of relay. There's an automotive relay, some are AC relays, some are DC. And what it is it's a controlled switch. So by using one voltage, we can control a switch. Now in the case of this exact power supply, the Shure Electronics, we can use the 12 volt AC fail as the control for the relay. So I'm going to show you how to connect that relay, but I understand that many people do not have this nice AC fail connector on their power supply. So I'll also show you how to get the signal from the mains and use that as your relay input, and I'll show you that too. So this video is going to be a little bit long because I'm going to be showing you two different relays. The one is a DC relay and the one is an AC relay, and you'll see what I mean by that shortly. Right, so let's start with the one where you've got 12 volts on the main board here. Right, I'm going to quickly explain how a relay works because this is part of the installation. Now you can see that I've got this coil here, and the minute I give it 12 volts, this coil magnetizes this contact here and it pushes these two pins together. This pin travels there and it actually shorts out these two pins over here. So if I had to measure the continuity here, it will actually be shorted out. The minute I cancel the 12 volts, these pins separate, and what happens is it's an open circuit. I'll just quickly demonstrate that for you. So over here I have a relay. 2 pins are the coil and 2 pins are the contactors. The coil and the contactors do not actually touch each other. They are galvanically isolated. So what that means is by using these 2 contacts over here, I can control what happens on these 2 contacts over here, although they are not touching each other. If you want to understand this in more detail, please check out my electrical playlist. There's some videos there on relays. Right, now over here I've got 2 relays. This is a DC relay and this is an AC relay. For the first part of this video, I'm going to be using the DC relay. And the reason for the DC relay is the output coming from here is DC. So I need to connect this 12 volts to this over here. Right, now I've already soldered 2 wires onto this side of the relay, and how do I know where to solder it? Well, you can use your multimeter, and watch what happens when I measure this. I put it to resistance on my multimeter, and when I measure this, you can see it's 274 ohms. That's telling me it's the coil side, but the reason why I've used this relay is because it's got a window here, and I can actually show you that this is the coil side. Now over there's the contact side. So you can see that I've got 3 sets of contacts here. So what happens is when the relay operates, 2 of these contacts are going to short out while the other 2 are going to open. And then if the relay is disengaged or is no longer energized, then this 2 contacts that were closed now become open, and the contacts that were open now become closed. I'll show that to you shortly. So having a look at the ohms on my meter, when I touch these 2 leads, you can see that it's a dead short, 0.0 ohms. And if I go like there to there, it's open. And if I go from there to there, it's also open. So what's happening here is while the relay is not energized, these two are closed. Now in this case, when the mains fails, this over here actually goes on. It becomes 12 volts. So in this case, I'm going to connect this to the mains fail over here and the negative. Right, now what I'm going to do is I'm going to show you the mains is plugged in. So you can see how the relay looks. Now I'm going to unplug it and you're going to see the relay disengage. Right, so I'm just about to unplug it and there it's unplugged. And do you see the contacts have changed state? Now when I plug the mains back in, right, so that's going to be providing me that controlled switch. Because now as it stands, the LED light is on all the time. I don't want it on all the time. All I want to do is have it on only when the mains fail. So that means I have to put this relay, the contacts, in series with the light. What I'm going to do now is I'm going to open the positive of this light circuit here. There it is. You can see the floodlight has gone off, and I'm going to connect this side to the relay. Right, so all I've done is I've added this wire. And if you see, if I touch it on here, you can see that the LED light is coming on. But what we want to do is now put this relay in series. So which contacts do we use? Well, let's think about this logically. There's the meter. The mains is on, so we don't want the light to be on. So if I measure between here and here, it's a closed circuit. So that means that this would put the light on if I use those two contacts, so that would be wrong. If I measure between this one and this one, it's an open circuit. Now, if I switch off the mains, watch what's going to happen. The relay is operated, and can you see that the other contacts have now become shorted? So I already can see that I want to connect the LED light there and the return wire there. Right, so now we have the relay connected. Just to summarize what's happened here, we've got the output, which would normally be fed to the load. If I had the positive and negative of the LED light here, it would be on all the time. So what I've done is I've connected a set of relay contacts in series. There you can see the LED floodlight, but then the positive of the output here is going via the relay contact. So if you see there, it's got to go. It's coming in there, the contact is closed. There you can see that the two copper platforms touching each other. Then it's going down there, it's coming out and going into the LED floodlight, which is on. These wires over here are the energizing coil wires, which are coming from the negative, and the positive, which is the AC fail, which is on this power supply. I know that not all power supplies have it, so I'm just showing you if you're using a power supply that does have an AC fail on board. And here, this is a 12 volt relay. You read the relay specs on the side, and it's actually written there 12 volts. Right, so the light is on. Why is the light on? Because the mains is unplugged. So it's actually operating from the battery. Now I'm going to plug in the mains, and the relay is going to activate and actually open those contacts. Look at that. So now what we've effectively done is made this floodlight only come on when the mains has gone offline. There we go. Now what happens if you haven't got this 12 volt output to tell you that the mains is offline? You can still do this using the mains as the signal for the relay, but now you'll need a 220 volt or the line voltage relay. In my case, it's 230 volts, and I'm now going to show you how to use the mains voltage as the voltage that controls the coil of the relay. Now, because we're working with mains, there's a shock hazard here. Right, now I've removed the 12 volt relay, I've disconnected the wires, and now we are going to be using the mains as the relay input. But now there's a shock hazard here, because remember that this is now using mains voltage, and mains voltage comes with a major shock hazard. So please be careful here. Now in this case, the country that I'm in uses a 230 volt supply. In your country it might be 110, but nevertheless the same principle applies. Now over here I've got two relays. These are both relays that would be suitable for my supply. Why? Because it says V230, 230 volt input for this relay. This one also says 230. There you can see 230 volt. How you could test that is if you took your multimeter and measured across the coil, you will see that the ohms between the two coil wires is much higher than, say, the resistance of a 12-volt DC coil. Why? Because there's far more loops in the coil, increasing the resistance. So now in this case I've got two relays, and the reason I've got two relays, this relay is a double pole single throw relay, which means that I only have a single set of contacts. So when I energize the coil, these two contacts will touch each other, which means these two terminals at the bottom will become a short circuit. But in this case, because I'm wiring it to the mains will be connected directly to this coil. So if the mains fails, then these two contacts are going to be open. If these two contacts are open, my light is going to be off. So this relay is not going to work because it doesn't have a double throw. Now here you can see I've got a double throw. I've got a contactor there, one in the middle and one on that side, which means that when the relay has not been energized, I've got a dead short between there and there. When the relay gets energized, I have a dead short between there and there. So when the relay is not energized, nothing is connected, I've got a dead short between there and there. So that would be suitable for my setup because you can see the contacts are already touching each other. So I could use this for the output of my LED floodlight being on. When the mains goes on, connecting here and here to mains, the relay will activate, pushing the contact to that side, and it will open these two contacts, which will then in turn switch off my floodlight. So that is why I need to use this relay. And just for your reference, here is some diagrams. Single pole, single throw, single pole, double throw. This would also be fine. The one I had was double pole, single throw. You can see there's only on off. There's no condition where when the relay is not energized that a contact is closed. That's why it doesn't work. Whereas this one, even when the relay is unenergized or off, can you see that there is a set of contacts, I only need one of them, a set of contacts that remains closed. That's why I need a double throw. So ideally you could just get a single pole double throw relay and you'd be fine. Right, so what I need to do now is wire up the mains side. Now over here I've got the mains, and all I'm going to do is make a small incision there and there, add my two wires, include a fuse and wire it to this relay. Now, hopefully in your case, on your power supply, you don't have this type of connector. You'll have the one where you're using a screw to tighten it. In that case, it'll be much easier because you can just put the relay wires in parallel and then tighten the screw. Now remember, the power must be off. Now in this case, I'm adding a series inline fuse. Why? Because now I'm connecting a circuit directly to mains, and you should fuse any circuit that is connected directly to mains, especially when you're adding a little modification here. Right, now I'm just soldering the other side of the fuse to the relay contact over here. Right, so to sum up, there's the live and the neutral coming in from the supply, from your mains supply. Then I've connected an inline fuse, always connected to the live. There's my fuse. It's just a 1 amp fuse. A relay uses a very low current, probably less than 0.1 amp. So from the mains, there's the live going through my inline fuse, 1 amp, connecting directly to the terminal of my relay. On the other side of the coil terminal, it goes to the neutral. So when I plug in the mains, this relay should operate. You'll hear it go click. But now you've got to be careful because this is mains voltage now. So over here, you're sitting with your 230 volts. So you've got to be careful. You've got to make sure that you keep this separate. Or ideally, you could put it on something called Vero board and put it in a little box when you're done. But in this video, I'm just showing you the principles. You'll do it safely and neatly in your own installation. Right, now on the other side of the relay, I need to connect it to the light. Now, if you remember, this is the output from our power supply. So this is my 12 volts. So I can connect the one side to the one contact of the relay. And only when this is closed will my light activate when I connect the other side of my light's terminal to the terminal of the relay. In terms of relays, we have something called normally closed and normally open. So these are the normally closed terminals. And when you activate the relay, these will become open. So right now they are normally closed. Look what happens when I touch the wire on that other terminal because it is normally closed. So I'm just going to solder that on now. I've got the output from the power supply going to the relay contact in series. You can see this is actually a series. It's almost like a series connected controlled switch. Look, it goes up through there and to the light. Now look, the light is on. Why is the light on? Because these are normally closed. Only when I switch on the power now and these two go to the supply voltage, mains voltage, will the relay operate. When the relay operates, those contacts are going to open, switching off this light. I'm going to demonstrate that now. As you can see, when I plug in the mains, you're going to see that the relay is going to operate and it's going to turn off the LED floodlight. When I unplug it, the contacts close and the light comes back on. Right, so now you can see the light is back on. Why? Because the mains is unplugged. And there you can see I've showed you how to use the mains voltage as the input to the relay to control the light. Here in this case, this LED floodlight. Now I'm going to remove all of this and connect it back with my 12 volt setup. Right, I'm now going back to the DC setup. This is if you want to use a DC relay to notify you when the power is off. And I'm actually going to use something called a relay board. This is a little relay board. All it does is it takes the contacts of the relay and wires it to a terminal block like this. Just makes it easier to use the relay. Right, now I've closed this up, so this is safe. I'm going to reconnect this onto the main board. And you can see that I've connected a little relay board here. So there's my positive and negative that feeds my relay. So these are the wires that power up my relay. This is a DC relay, so there's the positive and negative. Here on the board, you can see it says NO, NC, common, and there's the positive and negative. The positive and negative is just to power the relay. That is coming from these terminals over here. Remember that this power supply has the option of telling you that the AC has failed. When the AC fails, this actually goes positive. So this is actually the reverse logic of the AC setup that I just showed you. The DC setup in this case, when it goes positive, the relay operates, which means the relay is now on. This little LED is actually telling me the relay is on. So that means I've got to use the reverse logic when it comes to the output terminals of the relay. What I mean by that is, as I said, the relay has a normally open and a normally closed contact. So in this case, when the relay is activated, the normally open contact is now closed. I've connected this in series. So there you can see the output from the power supply. This would be feeding the load, the LED light, comes there into the relay on the common, and it leaves on the normally open. Why normally open? Because the relay would be normally open if it wasn't energized. But because I'm getting 12 volts from here, only when the mains is off, then it is activating the relay to switch on this light. So when I plug in the power, this goes off, the relay goes off, and the normally open actually becomes open circuit or normally open. And there you can see the light goes off. So there's the setup if you've got a nice little relay board, but there's nothing stopping you from just wiring it directly onto a relay such as this. And if you're going to be using the main setup, I've showed you how to use the line voltage type relay. Obviously, you're going to put this in a little box and make it neat. You would close this and there would be your light. And only when the power goes off, you'll see the light goes on. And there the light goes on. And when the mains comes back online, there the light goes off. Now last thing, what happens if you want to have this outside and the mains goes off, but it's in the daytime and you don't want the light to be on while in the day? Well, the last step is just to add a day-night switch. So as you can see, the light is on, but I don't want it on now because it's going to be outside. I only want it to be on if the power's off and it's dark. So now what I do is I use a day-night switch. So here is a day-night switch which I purchased. This is a 12 volt DC day-night switch. Why 12 volt? Well, remember that the output here is 12 volts. So we're working with a 12 volt light. So I only need a 12 volt day-night switch. Now how the day-night switch works is there's an input and an output. All the day-night switch is going to do is it's going to act as a switch, as the name implies. When you cover this little window here, it's going to know that it's dark and it's going to allow current to flow to the light. When you're not covering this, or if it's daytime, it will block light, it'll block the current going to the light. I'm going to quickly wire this into the circuit to show you what it'll look like. Now this day-night switch came with these DC jacks, but I'm not going to use them, so I'm just going to cut them off. In your case, you could use them. Right, so there is my little day-night switch. You can see the input, positive and negative, and the output, positive and negative. So all I need to do is get to the output of the relay. So this is going to feed the light. There we go. And all I need to do is put this in line with the light. So I'm going to take the output for where the light goes. See, there's the light. And now I find the output side. So this is the output. So all I need to do is connect this to the light. Right, so now the day-night switch just needs to be connected where the LED light was. So the positive was connecting to the relay over here. And the negative was going back to the supply. Now I will draw a diagram and show it to you at the end of the video. So I'm just going to show you this working now. So what we have now is mains off, running on backup power. When I cover this, you can see how the light comes on. Now I'm going to plug this back in. Mains is on. It's going to disengage the relay. So even if I cover this, look, the light cannot come on. So now what we have is a backup power supply that can activate the LED light when the power is off and when it's dark. So now this is a outside backup power supply for your light. Right, now I'm going to show you the diagram of this so it'll be easier to follow. Right, so here's a quick diagram of the method that I've just shown using the DC relay on the Shirlatronics power supply. So there's the LED light connected via the day-night switch. There you can see if you didn't use the day-night switch, you would just cancel this and connect the positive there and the negative there. So the day-night switch is just in line. The positive goes to the positive, and the output positive to positive, and the negative to the negative, negative to negative. So this is just in line. Now going backwards, you can see that the day-night switch is connected on the one terminal to the power supply and via the other terminal to the relay. And your relay is fed from your main board on the Shirlatronics power supply. So if you have a look here, I'm going to go in the other direction now. From the output of your power supply, that would have normally just fed your LED light directly. So there you can see. And watch what happens. One wire going to relay. There we go, to relay. The output of the relay to the day-night switch. There we go. Output of relay, there. Coming to day-night switch. The negative of the day-night switch going all the way back to the output of the power supply. There we go. There's the negative of the day-night switch. You can see there's a negative of day-night switch. Then the output of the day-night switch, positive and negative, both connecting to the light. Output of the day-night switch, positive and negative, both connecting to the light. Now, as I showed the AC setup, if you were going to connect your relay directly to the power supply's incoming mains line, this is what the diagram would look like. The live coming in, whether it's 110 or 230 or 220, you can see it comes into the power supply to feed the power supply. The neutral also coming in. All I did is I buddied off there, so I just opened that wire. I just joined it there, so live coming in via a fuse, 1 amp fuse is sufficient, connected to the one side of the coil side of the relay. The other side of the coil side going to the neutral. So you can see that this relay is actually in parallel. Now in this case we would want normally closed. Normally closed connection because it should be closed when the mains is off. When the mains is on, it should actually open. Now as you can see what I'm talking about, this is the AC section and this here is all DC. So the beauty of the relay is it is galvanically isolated. So this AC current here cannot get to these contacts, these relay contacts, because they are galvanically isolated. Now the connection on this side, all of this is all the same as the other setup. The only difference is that in order to control the relay, I'm now using the AC instead of DC. Over here, you've got the day-night switch, and if you didn't want the day-night switch, you would just disconnect it. The LED floodlight would connect directly to those terminals. Right, so there I've mounted the power supply outside. On the side of it is the little day-night sensor. Just on the right-hand side is the day-night sensor. Then there's a cable that runs along the wall, and there is the 12-volt floodlight. The floodlight is currently on because the mains is off. The mains power that feeds the power supply is running along the wall. There's the black wire. And for now, I've just plugged it in here. You can see that the power is off, and that is why the floodlight is on. If I had to come here and switch this on now, the mains power is on, even though it's in the night, the floodlight is off now. Right, thanks for watching and cheers.